Welcome to the Fire Sprinkler Podcast with Chris and Logan. This episode of the Fire Sprinkler Podcast is brought to you by General Air Products. General Air Products continues to be the fire sprinkler industry's primary source for all dry and pre-action system filling needs. Whether you need compressed air, dry air, or nitrogen, General Air offers each and is the only company equipped to advise you on the pros and cons of each filling solution. General Air Products also offers a complete line of 13D residential pump and tank systems. Visit www.generalairproducts.com for more information. Hey everybody, before we get started on this episode of the Fire Sprinkler Podcast, I want to touch base on a new fire protection podcast that is coming out, and that is the Fire Protection Podcast powered by InspectPoint. Drew Slocum has been on the Fire Sprinkler Podcast. I believe he was the first interview I did back in September, and he has now branched out and has started his own. He's going to do a fire protection in general podcast. It's going to be awesome. I've heard 3 or 4 episodes I think he's released now, available on iTunes, Spotify, Stitcher. I believe he's on all platforms right now. Go out, give him a follow. He's got an excellent product there as well. And yeah, give him a review, leave a review. And thanks for supporting both of us. Big thanks for supporting the Fire Sprinkler Podcast. If you want to support the Fire Sprinkler Podcast anymore, go to www.firesprinklerpodcast.com. You can purchase hats. I'm going to have some shirts coming out here soon. And leave a review on iTunes, Spotify, or anywhere else you can do. Like it, favorite it, do what you need to do. What that does is just kind of helps the podcast get out there a little bit better. You can come stop in and see me at the North American Fire Sprinkler Expo, which is hosted by NFSA. That is in Nashville, Tennessee on May 14th to 18th. I'll have a booth at the expo. Stop in, pop in, come see me, and let's talk sprinkler. Without further ado, here is my conversation with Ray Fremont from General Air Products. Hey everybody, thanks for tuning in to this episode of the Fire Sprinkler Podcast. On this episode, I have Ray Fremont, the marketing director from General Air Products. Ray, how's it going today?
Great, Chris.
It's a lovely. Yeah, it's good to have you on here. We've been talking about this for a little while, and it's good to finally get you on. It's a beautiful Sunday morning in my neck of the woods. It's raining out. The wife took the kids for a nice little drive so we could record this on a Sunday morning. How are things down your way?
Beautiful spring day outside of Philadelphia.
Oh, nice. So whereabouts are you from?
Just Pennsylvania, southeast Pennsylvania. So I'm born in Philadelphia, and we're finally getting our spring weather here.
Time to get the yard
well earned
and all that stuff.
Yeah, right. Yeah.
So Ray wanted to come on and talk about a few different things in the industry right now regarding the air supply decisions and products that General Air Products have on. So why don't we start with kind of starting from the design point of view when selecting a air supply for a dry or a pre-action system? What kind of a thought process goes into and how is General Air Products trying to change that thought process as far as instead of just going to any, fire protection supply, supply store and just picking up a General Air compressor off the floor? What thought should go in when selecting that?
Well, I mean, the first thing is I feel like we're winning if we just get people to go to a fire protection supply store rather than just like a home supply store, because very often we see air compressors out there that are just like, they got at Home Depot for $99 with a coupon. And
that's right.
It's just like, and we see a whole heck of a lot of that. So I guess that's almost the starting point there is, there's a lot of differences between, say, what people in the industry call a fire protection air compressor versus a standard air compressor.
So let's touch on that for a little while. NFPA 13 allows you to use an unlisted air compressor if equipped with an air maintenance device.
That's right. Really, UL listings start at the air maintenance device. Anything before that is up to you.
Right. So now, what are the benefits of using a listed listed for fire protection air compressor. Now, the company that I work for, my family business, we use listed air compressors on everything just because the quality's there. You know it's going to
Yeah.
work when you need it to.
Right.
What's the difference between a listed and an unlisted thing?
So, I mean, there's a lot of difference. I mean, for starters, the air compressors that are used outside of the fire protection industry, whether it's, I mean, you have a lot of different levels. So let's start with the lowest level where you have kind of like a retail style air compressor is what we call them. It's the stuff that you get off the shelf at Home Depot. They have about a 500-hour run life tops. But the thing is, it gets to be where I think a lot of people, a lot of people in the field will think, well, I bought that Husky air compressor or that, whatever, brand air compressor at the home supply store. And it's been working, I've been using it for 10 years. And it's like, yeah, well, it's been sitting in your garage and you use it about 5 minutes a year,
Yep.
So yeah, in that regard, it will last you a long time. But in a fire sprinkler system, the air compressor is asked to run quite a bit sometimes, especially as the system ages.
Yep.
So when you need those run hours. So when you're talking about a fire protection air compressor, you should be talking about something that's it's a really high quality industrial duty style air compressor, where you should be seeing anywhere from 5 to 8 or 10,000 run hours as opposed to 500.
Oh, wow.
So, oh yeah, it's monumentally different, and that has to do with every component that goes into it. Is a much higher quality piece. The conrods, the eccentrics, the crankcase, the fan, the motor. I mean, the motor is of huge importance in that the quality level that the motors are built to. I mean, again, it spreads the field a bit, but I mean, if those little race cars, that you have on a track and stuff, they got motors in them. And there's a level of quality to that, and there's a level of quality to, say, a motor in your own car, and in the fire protection world, we're asking these motors to do quite a bit. Like, motors want to run.
Yep.
They have a duty cycle, and they run efficiently when they're, running for, several minutes, say, 30, 40 minutes, and then off for 30, 40 minutes. Usually that's kind of a pretty efficient way for a motor to run. But that's not how motors run on air compressors and fire sprinkler systems. It can be for 2 seconds or 5 seconds or 2 minutes.
Right.
And then off for 3 hours. And I always try to tell people, it's like, when you're talking about, let's go back to the car idea, like your own car. If, your car gets great, your motor's running because you took a drive all the way, down the highway and everything, you're good to go. And your motor's fine with doing that because that's how it was meant to operate. But if you were to take your car and just turn it on and drive it to the end of your driveway and then turn it off and let it sit for 4 hours and then turn it back on and drive it back up your driveway, and that was the only way you used your car, you really couldn't reasonably expect to get 100,000 miles out of the life of that car.
Right.
The motor is not meant for off, on. But again, for the motor for a fire protection air compressor, that's exactly what we're asking it to do. So in order for it to be capable of doing that, you need to have a really robust motor. And that's what anybody, General Air, we make fire protection air compressor, and there's a couple others on the market. Most of them are, most of the air compressors that call themselves fire protection air compressors are built to a standard like that.
Okay. So now when you say the air compressors, the common term is a short cycling. If it's a riser mounted air compressor, will come on and kick off and come on and kick on and come on and kick off. Are those riser mounted air compressors, obviously having a listed one, you're going to have it's going to be capable of taking that higher demand for a longer period of time? You're not going to be replacing those riser mounts. Is that safe to assume?
Yeah, you're close, I think. So the only thing I would be concerned about there is with short cycling in and of itself. If a unit, especially a riser mount, they're the ones that are most prone to it, is on for a second, off for 5 minutes, on for a second. What you typically have there is a leak in the airline somewhere, and that needs to be addressed. The compressor will keep doing it; will be fine doing that. You might get electrical problems. You might short the breaker. There's a variety of things that could happen there, but overall, yes, it can withstand that for a certain amount of time. Whereas, but just if you think about a compressor running when it's not, say, short cycling in a negative way where there's no air leak. Let's say it's just running where it's like, let's say once an hour it needs to come on and it takes, 3 or 4 minutes to fill up the system, and then another hour later, that on off is really hard on the motor.
Mm-hmm.
And it's like I said, that's like driving your car to the end of the driveway and then just shutting it off for the rest of the hour and then driving it back up. It's just that starting and stopping is the stuff that is really taxing on motors and compressors. And in a fire sprinkler application in a dry system or free action system, that's standard. That's how they're supposed to operate, So you need something there that's really strong from an industrial build standpoint to be able to do that and do it for, say, for General Air, we expect 10 to 15 years of life out of all of our compressors. So,
wow.
And we see a lot of them go a lot longer than that.
Right. So that's comparing an unlisted air compressor with a 500-hour run life, right? The Home Depot special, or the
right.
TSC special, to a 5,000 hour run life on a listed air compressor, which is typically what you're going to get at a General Air products.
Yeah, 5 to, a lot of ours are actually testing around 8 to 10. So,
wow. Okay.
Yeah.
So what now, how do you guys come up with that? Are you guys running those things? Like, what's the testing to say they're coming around an 8 to 10,000? Are you guys running it for 8,000 hours?
Yeah, actually, it's cool. Next time you're in the Philly area, you got to stop by our place. I love showing it off and giving people tours. But we have what a lot of people, I guess, at our building call a kill room, because nothing gets out alive. So we have a whole room where
don't threaten me with a good time. I'll be in Philadelphia in 2 weeks.
Right on. No, we have this room where it's like, like we'll have a vendor say to us like, hey, we think we got a better design for your Conrod. That we're going to get 8,500 hours instead of 8,000. And we say, okay, send us a couple. So they send us a couple, we build a compressor around them, and we run them until they die, And so anything new that we do, and when we're prototyping, our new builds, like the current oilless compressors that we're building now, we started building about 10 years ago. So for years before that, we were life testing them, and we continue to run life tests on them. We have probably about 20 or 30 running in that kill room right now.
Wow. So I'm assuming that's a soundproof room.
Oh, no, it is not. We love that. The sound of air compressors is a beautiful sound.
Depending on who you ask. I've got about 150 building maintenance managers that would say otherwise.
Well, you know what, Chris? That's a great lead-in for, the next thing, which is another decision that you can make is, should it be standard, noise, or should it be a quiet air compressor?
Right.
So quiet air compressors are on the market now, and it's because those facility managers are exactly right. They're telling us that these things are noisy, which, we're a little slow on the uptake over at General. So we were just like, what do you mean they're noisy? It's the same amount of noise that it's always been,
Yep.
But what happened was design started to change. And, you have an attic system with a dry valve that's right outside of somebody's apartment or condo or something like that. You have them, in libraries or golf clubs. One of my favorites was we had a compressor right behind like a choir box at a church that seemed to be going off as soon as the guys, everybody bow their heads for a moment of silence there, and all of a sudden my air compressor does not sound beautiful in the middle of a sermon. So, but so again, we came out with a line of quiet air compressors, and we still have a separate line because we offer them as it costs a little more to build them.
Mm-hmm.
We lose some flow when we're eliminating the sound, but it's just so I guess, one of the decisions somebody should think about when they're deciding on what type of air compressor to use, say it's a riser mount, okay, we've decided on a riser mount. So we have a riser mount quiet or standard, as far as sound goes.
Mm-hmm.
And, our whole thing on it is if you got a dry valve that's by a loading dock, who cares how loud?
That's right.
Save yourself a couple bucks and go with the standard riser mount. But if you got one that's going to be right next to Mrs. Smith's, bedroom, at her condo or whatever, you're really going to want to think about, you might as well get out in front of it and get yourself a quiet air compressor. So
that's right.
Yeah. So you're right. Not to your point, I guess ultimately not everybody thinks it's a beautiful sound, especially at 2:00 in the morning when you're trying to sleep. But
that's right. So
but I would disagree with them a lot.
I typically you're selling them, so of course you like the sound of them. I like the louder air compressors because that's if you're not getting your air compressors coming on before you get a low pressure at the fire alarm panel, but if you are constantly hearing your air compressor, you have an issue, and it may not be a trouble or an alarm issue, but you have a problem with your system that needs to be adjusted, and it's going to be even more annoying when that air compressor can't keep up and it runs all the time, and then you get a low pressure and your fire alarm company, your monitoring company is calling you and telling you got an issue. So
you're exactly right. Yeah, that is a drawback to it. When you pick a quiet one, you really should. And this is another thought that should go into it is, okay, now I'm thinking about put a quiet one in here. Is there somebody like a facility manager that knows to go around and eyeball all these things, to get that close to them? Because if there isn't, and that's another big part of, say, air supply decisions is what level of maintenance is going on. All the air compressors need some sort of maintenance, on a regular basis. And, if you can get somebody to be looking at them quarterly, you're in pretty good shape, I would say, overall.
That's
even
right.
though there's, it should be more than that. But, I mean, really, let's, be realistic. And if somebody's looking at it quarterly, so that's another really good point is the idea that if you have a quiet air compressor and it's short cycling, well, it's going to be so quiet that nobody might even realize that,
Yeah.
And then you could have that short cycle to the point where it trips the breaker and then it shuts off. And then you're going to be looking at a low air alarm very quickly.
That's
so
right.
If somebody's not paying attention to that, yeah, man, that's you're right on with that.
Yeah, it's one of the questions I ask when we're doing inspections, and a lot of people do ask when they're doing inspections. Is it's not listed anywhere in NFPA 25, so it's more of just a verbal question. Have you noticed your air compressor running a lot lately? No, okay, that's good. That's kind of an indication that you may not have any problems until you get to the valve room and realize your valve's been tripped for 3 months. But it's one of those things you can ask the customer just to get an idea. Oh, you know what? Yeah, that air compressor kicks on 2-3 times a day. Well, have you considered, taking it to the next level and actually finding a problem?
Yeah, right. No, that's exactly right.
Yeah, a lot of people have their own tricks and tips for finding leaks in systems. You hear a lot of people saying to flood it, what you can't do in an attic system in the middle of winter. But
Nope.
Adding mint to the air compressor tank and then pumping up the system from empty. Have you heard all these? Yeah.
Oh, I love that one. I do.
Yeah. As long as you don't get it all over your hands, you should be in good shape and you should be able to find it. But if you cover yourself in the mint extract, you're gonna say, "Oh my, the whole system's leaking." No, it's just your hands.
Smells like mint.
Yeah,
we got a serious problem on our hands.
Geez, everything's leaking but the hangers on this system. It smells like even down in your office, it smells like mint. This is crazy.
Yeah, right. Yeah. No, I love those kind of solutions to things, and actually, I use that example a lot when we're talking about freezer rooms and the type of equipment that you should be using in, say, a freezer or a cooler application for air supplies. So, and that's kind of a good lead-in to that kind of conversation because, one of the things like we've, in addition to doing air compressors that I want to get back to, but we'll also, with nitrogen and dry air. So freezer rooms is a place where we developed what we call our dry air pack, which is a dry air generator back in the mid 90s. And we've been putting that into, it's been a pretty industry standard piece of equipment to use for freezer rooms and dry systems and freezer rooms for the past almost 30 years now. But people have been introducing nitrogen for that application. And one of the big reasons that we think, I mean, there's several, but one of the biggest reasons is that, even if you take care of corrosion with your nitrogen, you're still going to have a lot of air leaks. In a dry system or a pre-action system, air leaks happen. Corrosion is one of the factors, not the only factor. So there's going to be all these factors that cause these systems to leak. And if when you're talking about a freezer room system, addressing air leaks in a freezer room system is closer to impossible than improbable. It is a very, very challenging thing to have to do. And with so I guess the tie-in with what you were saying before with the mint is there's several ways that you would do that, right? So to find air leaks in a dry system, our super high-tech way of doing it in general, when we're testing all of our compressors, soapy water, right?
That's right.
You find a bubble, right? You find a bubble, there's a leak, you're done. Well, you can't do that in a freezer room.
Right.
Right. And I mean,
I have been that guy that tried, though. I have. You spray it,
you might
and
have
you get an icicle.
Right. Yeah. So you might have actually filled the hole, right? So maybe you even did fix it that way. But no, I mean it doesn't really work well. And then the next thing is the mint extract, which, like I said, in a lot of places I like, but typically a freezer room is one gigantic room with several gigantic blowers in it. So all you're going to do is make the whole freezer room smell like mint,
Right.
so it's not going to get you there, and so, that leaves you with like ultrasonic leak detection and things like that to do, which are very effective, but, it's expensive and it's time consuming. It's going to be, 10 times more time consuming in a place where an environment you can only be in for 5 to 10 minutes at a time.
Right. Yep.
So, so that tells us that you want a compressor for that application. And again, we think of dry air generators, nitrogen generators, air compressors. They're all air compressors. A nitrogen generator is an air compressor with a fancy filter on it. You put a different fancy filter on it, you get helium or whatever. So you can do all that. So they're all air compressors. But for a freezer room, you're going to want an air compressor that will be able to keep up with leaks, that's not going to cause corrosion, that's not going to allow for ice plugs. And the only thing that fits all that is dry air, because nitrogen generators have severe problems with keeping up with leaks. They have a very, very low flow, which, like I said, we can get into. But I just thought that was that mint thing. I don't hear a lot of people bring it up. I bring it up a lot, and it just reminds me of that whole issue with freezer rooms, and that that's the only way to keep up with those air leaks is a compressor with a lot of flow.
So I see you guys at General Air Products sell both nitrogen generators as well as the dry air packs, the generators that produce the dry air. What aspects and what kind of an environment would I go one way or another on these type of systems? I'm designing. Let's just start with that. Like, what kind of an environment is better suited for dry air, and what kind of an environment is better suited for a nitrogen generator from the ground up, not a system that's been in for 10, 15, 20 years. If we're going from the ground up, why would I select which kind of system?
No, great question. Day one, to me, I mean, right out of the gate, that you can go by application. So in regards to freezer room, oftentimes I would say in most cases a dry air generator is substantially less expensive than a nitrogen generator. But even in the instances where the dry air generator is about the same cost, or even if it's a few dollars more, any freezer room, somebody calls up General Air and says, hey, I have an application for a freezer room. The answer is going to be dry air pack. I mean, if somebody really twists our arm, we're going to quote the nitrogen generator, but I would much rather be putting the dry air pack into that application. So application can tell you part of it. The other part, though, is for a day one, any kind of dry system, let's take freezers out of it for a moment. Mm-hmm. I would say that for nitrogen or dry air, how much water is going to be standing in that system? That's going to be one big question, because, as we talk about, these are corrosion solutions. The biggest thing that we can control in the industry, as far as a corrosion solution goes, is getting water out of the systems, trapped water out of the systems. If you have a system that is properly, and frankly, this is the number one way to fight corrosion. It's proper installation. Mm-hmm. Proper pitch and proper drainage is going to get you most of the way to not having a very corrosive environment inside of your pipes.
Right.
If you have that, and what we really recommend for people is like on day one is saying, if you don't know if you're going to have a corrosion issue, you're not sure one way or the other, put a standard air compressor on it with a tank so that you're getting most of the moisture that the compressor generates to drop out into the tank in liquid form. So it's not,
Right.
you're still getting some water vapor going downstream, but not nearly as much as you would if you were directly pumping it in with, say, a riser mount. So you do that, you get it into the system, and then put some corrosion monitoring devices on there. There's a handful of products out there. My favorite is the one by AGF. They make a Core Insight, it's called. That's a really cool little product that does from a mechanical point of view, and it's a color change that actually is triggered by corrosion in the pipe. And what happens is if the ticket inside of the Core Insight corrodes, it allows the color change on the outside to be a visual indicator that, yes, there is corrosion taking place. And so to me, day one, and you're not sure you have corrosion, I put an air compressor and some of those corrosion monitoring devices on there. A couple years later, if they start to change color, well, then it's time to put a nitrogen or dry air on there. But if they don't, then you never needed it in the first place because you got most of the water coming out of your system.
Yeah, I did.
So,
Actually, I did have Jim McHugh on from AGF, and he was talking about the corrosion monitors. I believe it was an episode in February. If you want to go back and listen, but yeah, very very interesting. Does General Air Products have anything like that, or do you recommend using the AGFs?
No, I recommend AGFs. They're actually another family-owned business like ours. They live. They're right down the road from us, about 3 or 4 miles away. And we buddy up on a lot of this stuff. And,
nice.
I just love their approach to design of their products. It's everything is a simple mechanical way of looking at things. And I don't know, it's old school. And I like that because I think it's very effective. Right. And especially you can see that in the Core Insight where, there's a lot of different ways people are doing it, but theirs is just like, yes, you have corrosion because it's actually happening. And now that you see that, it's time to do something about it.
That's right. It's very visual. And sometimes,
yeah.
Well, of course, you're telling me I have corrosion in my system. You're the salesman who's going to fix it for me, right? Where when you can say, look, this is no longer there. it's corroded.
That's
right?
Exactly right. I mean, I keep going back to a lot of this stuff with even prescribing nitrogen for everything. I keep going. It's like, yeah, well, if you ask a barber if you need a haircut, he's going to say, yeah. You know what I mean?
Yeah.
And like, so that's where, again, like General Air tries to come in and say, like, look, we have air, dry air, nitrogen. Let's talk about your application. Let's talk about the, what you're looking at from a design point of view or an install point of view, and let's prescribe the best medicine for it. Let's, what's the best way to approach this? And like I said, sometimes it's just going to be an air compressor with some corrosion monitoring devices. That's fine. But then let's say you have, like you were saying, on day one, how do we decide, well, how long does this building need to be up? Yeah, I mean,
right.
Again, it's kind of pragmatic, but like, nitrogen, we talk about it as a 60-year or 100-year solution. And granted, keep in mind, during that 60 years and 100 years, you're not buying one nitrogen generator. Nobody makes a nitrogen generator that lasts 60 years or 100 years. So
yep.
you're buying 4 or 5 nitrogen generators in that time at least.
Right.
That's if people are doing maintenance and all that kind of stuff. But again, day one, you decide on your, which way you're going to go based on, one of the ways is based on how long does this building actually be here? If we're talking about overhangs on a Tim Hortons or a Starbucks, if we're talking about that, then, those buildings are going to be knocked down and, or Timmy's is going to be out of there and they're going to put in a nail salon, after 5 or 6 years. And then after that, it's going to be a parking lot for a condo.
Right.
So, I mean, why are we talking about 60-year or 100-year solutions when we could be talking about, just let's take care of what we have in front of us? I mean, even stadiums only have a life of typically 25 to 30 years. So,
really? See, that's something I didn't know. Well, yeah.
Yeah, I was talking to, right? No. I had the same reaction. I was talking to an engineering firm out in Colorado, and they specialize in them. They were doing the Raiders' new place out in Vegas. Was one of the projects that they were working on at the time. And, I was thinking about it. I was like, I'm thinking about all the stadiums we've had in Philly, and it's only been a handful. But we always think about these stadiums as being there forever. But they're not. 25 to 30 years is really what we're looking at before they knock them down and put up a new one.
Yeah, the
So,
technology evolves, the things that you can have in the stadium change, and they wanna upgrade. Which,
yep.
when you talk about dry systems, the average lifespan in recent studies on a dry sprinkler system that you're installing is you're really only going to get out of the piping itself 18 to 25 years
Out of the pipe?
out of the piping itself. I've seen research. I believe it was a study by FM. One of the FM white papers that they released said that, like, if perfect conditions, you can expect, maybe to the higher range of 25 to 30 years, but in a corrosive environment, you're looking at like 12. But
Yeah, it could
the
be less. Yeah.
yeah, the average dry system is not a long-term solution
No.
anymore. And it's crazy to
No.
think of that. Everybody's using thinner pipe as well, right? Like, I still service systems that were installed by my grandfather back in the 70s and 60s. But
Yep.
you know what I mean? Those
Oh
those
yeah.
systems are going to last forever.
Yep.
Um, but yeah,
I mean,
nowadays it's just
again,
going
yeah.
different.
Sorry, go ahead. I know
No, no.
exactly where you're going with it, and yeah, I mean it's with these older systems, I mean, corrosion was never an issue before, but something changed with the environments of these sprinkler systems, be it the type of pipe, things like that. I mean, and again, I think it's where people need to do more due diligence with what pipe are we buying, and again, you get to the thinner and thinner. I mean, I mean, one of the stuff that kind of makes me kind of cringe a bit is hearing more and more about what's it called? Like people talking about stuff like Schedule 7 piping,
Oh yeah.
and
Yep.
I mean, and we're seeing it in places,
Yep.
and to me, if you want to put nitrogen on something, that's probably a better way to go, because that stuff's like tinfoil. It's gonna, it's gonna bow. It's gonna, with water in it. I mean, it's not a great installation, and under the best circumstances, you're going to have a lot of standing water. I think
Yep.
that the nitrogen can probably be best there,
Yep.
But I would say really your better solution is use, I mean, ideally Schedule 40, but nobody really does that anymore, but Schedule 10 or something like that,
Right.
with 10, and use like good proper pitch, proper drainage. You're dropping the vast majority of the water. You just have wet inside pipes. Now, like you said, if that pipe only needs to last 20, or is only going to last between 10 and 20 years, how long is the building going to be there? Is kind of the next question. And if you wanted to, let's say the building's going to be there 30 years, and we know that pipe's not going to last even under the best conditions 30 years. Okay, well now dry air is going to dry it out enough that, because you've got most of the water out, dry air is going to dry out the inside of that pipe, and it's going to give you that, to anywhere between, depending on how much water is going through there and stuff, anywhere between an extra, all the stuff that we've seen is almost on par with nitrogen. So anywhere between 50 to 70 to 100 years.
Really?
Oh yeah, we've got 30
Okay.
some pieces of pipe that we pulled out of existing systems, which is what I like about the testing that we did for dry air. When everybody did their nitrogen testing, ourselves included, when we did it, it was with a kind of a laboratory setup where we put tickets in, and that pipe was brand new, and then we're pulling tickets out every, say, 6 months or so to get analyzed. But what we did with our dry air, because we had dry air packs in the field, both in freezer rooms, but we also, in Canada, in northern U.S., where like, say Minneapolis, Boston, places like that, a lot of parking garages had our dry air packs in them because they were afraid of ice plugs in the cold month. So we would have dry air going through there. So we had them pull pipe from them, and we had that analyzed at the same place we had it, the nitrogen pipe analyzed. And the results we got back were, like I said, right in line with the 30-some pieces of pipe that we got back were all right in line with nitrogen as far as effectiveness goes.
See, that's interesting. That's interesting.
Yeah.
So how much of a corrosion, like, so you would put them in these freezer rooms and leave them for, you said 20 years, 30 years?
With the dry air packs, I mean, let's see, I want to say from the pipe that we've gotten back, it's the tricky part with getting the pipe back was finding somebody who could show us that they've been doing maintenance on this for that amount of time, because whether it's a nitrogen generator or a dry air pack, you need to do maintenance on it. And again, like, you couldn't pull 20-year-old piece of pipe on a nitrogen generator or in a system with a nitrogen generator, if you didn't know that that nitrogen generator had been actually providing 98% nitrogen for that entire time. Because
Right.
let's say they shut it off for 2 or 3 years, you're going to see a rampant amount of corrosion during those 2 or 3 years.
That's
so
right.
The tricky part was that, right? Same thing with the dry air pack. So we had to do the same thing there. And what we did on the dry air pack was I think the oldest one that we got was 15 years old. So we had a 15-year. I know we have a 13-year. We have a couple 8-year pieces of pipe. So again, hanging in pipe. There was a couple of docks down in Philadelphia, the piers down there. There was a couple from Nestle out on the West Coast. So there was a whole lot of pipe that we pulled from all over the country, and actually had that that pipe that was out in the field analyzed.
Right. So even after 10 or 15 years, what kind of results did you see? Did you see very little corrosion? Did you see substantial corrosion when using the dry? I'm assuming you saw little corrosion, but do you have any kind of a percentage point as to 2% corrosion compared to a regular air compressor, which was showing 20 or 30% corrosion?
Yeah, the way that they quantify it is, so when you give the pipe over to these metal or corrosion analysis companies, they look at it in terms of years before the integrity is breached.
Oh, okay.
So years before you get a hole. So on most of the samples that we got back from dry air, the determination, and we have a white paper on this that we're happy to share with anybody, but we have most of the responses that we got back was there was so little corrosion that they couldn't determine how long it would take for a hole to occur.
Really?
That was off. Oh yeah. So I mean, it's, again, when it's completely dry inside, again, you think about the corrosion triangle: air, water, and metal. To simplify it, you remove any one of those, and you don't have corrosion. So the easiest example and the best example is for freezer rooms, in that they only see water typically once. The actual branch lines and all the lines going into the freezer room. A lot of the freezer rooms the people that we talk to, actually did their tests, their hydrostatic tests at the beginning, and then after that, when they do a yearly or every 5-year test, they're circulating the water at the valve to show flow, but they're not actually putting it into the freezer room where the pipes are, because they don't want to shut down the whole freezer room in order to run this test annually.
Right.
You see what I'm saying? So they don't actually, so really, it's easy to keep a freezer room dry. And frankly, that's where, again, we say nitrogen is complete overkill there. And it's not an environment where you should be seeing any corrosion. So while we pulled some of these from freezer rooms, we kind of got we know where we're going to be with that. That one was easy. Dry air is going to protect that, no problem, because it has an endless amount of time to dry out whatever water is left over in that pipe, which is usually minimal. So that's, then when you get to parking garages and things like that, that's where I like the test the best, because those are ones that are annually seeing water. And the dry air pack is then annually drying them out. And the results that we got from most of those were, again, in line with what I was saying before. And some of them, let's see, I think the worst case one that we got said that there was going to be about a 60-year before there was I think it was a 3-year piece of pipe, and they estimated that 60 years there was going to be a breach of that pipe. And it was only at one spot. It was right at the groove. So we think that there was some water that was kind of trapped there that was kind of protected by maybe the gasket or something that didn't allow for the dry air to go across it. Which, again, if it was nitrogen, probably would have been the same thing, because the whole rest of the piece of the pipe was also had no problems with it. It was just that one spot. So that was the worst case one that we got back, was 60 or so years.
Interesting. Okay. So when you're deciding, okay, so I want to go back. We've hit on the nitrogen generators versus the dry air packs pretty good. What's the difference? What's the difference, and what is the selection process when you're going from a riser mount air compressor to a tank mounted air compressor? What are the benefits? There's got to be benefits for either one, or else you'd only sell one of them.
Right.
What's the benefit to one way or the other? I prefer a tank mounted air compressor because it's got that little bit of storage, less likely to short cycle in the field. But why are people buying riser mounted air compressors?
I really think it's just space. It's
Hmm.
easy to install on one little system. It also keeps costs down. So again, if you have a couple, so I think they're ideal for small systems. And again, you know how riser rooms are. They can, if it's a whole closet, you're lucky. You
Yeah.
know, so
Yep.
so I mean, it's so sometimes the space in there that's really to me the biggest thing. I mean, if I'm in a riser room, I'm always surprised, and my sales guys might not love this, but if I'm in a riser room where there's 10 systems, 10 valves, going down the wall there, and they got 10 riser mounts on there, I'm usually pretty surprised by that. I would probably take that 10 systems and put, say, 3 tank mounts in there. Now,
Right.
granted, depending on the size, you might end up putting the 3 tank mounts because we give a recommendation of 1 compressor for every 3 valves or 3 systems. It's a very conservative recommendation, but we think it's warranted. There's nothing in code that says that you can't put 1 compressor on 25 valves. Just
Hmm.
don't call us and say like, hey, your air compressor won't turn off. It's like, well, it's doing exactly what it's supposed to do. It's trying to keep
That's
up
right.
with all the leaks and all those things, right? So, but yeah, as far as the tank mount versus riser mount, it's really about space savings and it's less expensive. But to your point, I mean, our recommendation, anybody says, which way do you go with riser mount or tank mount? It's tank mount all day.
Hmm.
One of the things I've always loved with, like, say, dealing with Viking, they're one of the people who sell our product, and on all their cut sheets for all their valves, their people over there have always put a tank mounted compressor associated with that. And I've always appreciated that because it really sends the message of this is the right piece of equipment for this valve. And so tank
Hmm.
mounted is really the way to go. But riser mount has its place. I mean, again, it'd be, like I said, those riser rooms are so small that sometimes the tank mount is just not going to be an option. So
Right. Yep. That's fair. What other products does General Air what other kind of products does General Air Products have out there? I know my company has used the residential fire pumps in the past. Actually, we've
oh
used
yeah,
them quite a bit. I saw you guys have the new one out. I think we ordered 5 or 6 of them in the past 6 months of the H2 home.
yep, that's it. Yeah,
Yep.
we did just come out with that. It's got a really nice footprint. But yeah, we have, the history of our company goes back to the 1930s, and we've back then it was my great grandpop and my grandpop. They were working together selling all sorts of industrial equipment, and it included pumps and air compressors and blowers and things like that, filtration equipment, regenerative desiccant dryers, things like that. What we've done is over the years gravitated a lot of that equipment into niche uses like fire protection. And that's where, because people always say to us, especially with the residential stuff, it's like your General Air products and you got a water pump here, what's going on?
Yeah.
And that's where it kind of, that's where it comes from, is the idea that historically we've been selling pumps. We still have a large industrial division where we custom make and build a lot of process cooling equipment, like chillers and air fluid coolers, a lot of things like that. And then we'll supplement that equipment with, again, like nitrogen generators on our industrial side. All of these pieces of equipment we've used in all their industrial applications. And it's actually kind of funny because it's like they're new to the fire sprinkler world. When everybody was going on about nitrogen, we're like, yeah, nitrogen's been around for like, 30, 40 years. Same thing with dry air. As we introduced dry air to the fire sprinkler market, we were just like, everybody's like, well, does it work? And it's like, well, it's worked in every other industry that's been used for this exact same purpose for the past 30 years. So yeah, it'll work, and, but then that brings us back around to offering the pumps, and people are like, oh, I didn't know you guys had 13D pumps. So we have been doing them for about 15 years now. And it's a budding market. It's a very, very difficult market overall. It's very different. I mean, I think, if you deal with a lot of the residential stuff, it's a very different mindset from a
Yes.
construction point of view and equipment point of view and all that. But there's a lot of, and it'll actually be one day we'll have to get together and talk some more about that in depth, because there's a lot of issues with the pump and tanks. I think it's kind of a real Achilles heel for the residential industry, or residential sprinkler market, I should say, because there's not a lot of guidelines to what you should build. So we built a pump and a tank, but that we believe will stand the test of time when it's placed into a home where it may never run again until 10 years later, when it's supposed to just turn on and there's a fire. When there's a fire,
and it's expected to. Yep.
And it's expected to, and it hasn't run since the day we tested it in our factory.
Right.
Because there's no mandate to test them or make sure that. I mean, that's like I said, that's a whole topic unto itself. Which, like I said, it's scary, and it's a touchy subject. It really is. But that said, I think it's an important one to put to really be looking at, because I think that if I can't imagine any other piece of equipment that people would expect to turn on one time and then let it sit for 10 or 15 years, and then just would be disappointed when it didn't turn on immediately after 10 or 15 years. If you let your car sit in the driveway, it just wouldn't, you wouldn't expect 15 years later, like, I'm just going to turn the key and go for a drive.
That's right. Yep. There's also the aspect of it is life safety equipment, so people are expecting, they expect, without doing any maintenance on it, they still want it to work the way it's supposed to. Do a little bit of maintenance on it, and it 100% will, and you'll know that. But here in Ontario, Canada, the province, they have in the Ontario Fire Code, it doesn't specifically say if it's residential, if it's commercial, if it's industrial, whatever aspect it is. It says if you have a sprinkler system, you shall maintain it in accordance with NFPA 25. So that's where, so even though NFPA 25 doesn't have any requirements for inspecting residential, a lot of the AHJs and fire departments in my area still require you to inspect your residential sprinkler system 13Ds. We had a retrofit. You may have noticed in the past 5-6 years a big boost in sales in your tanks and pumps in Ontario. We had legislation come out where all care facilities, group homes, retirement homes, things like that, with more than 4 residents, had to be retrofitted with sprinkler. So it's been busy up here for the past 6 years. I believe that legislation came out in 2012, and they had up until January of last year to retrofit all group homes, which are essentially single resident homes, with sprinkler system. So anyone from 4 to I believe it was 4 to 10 residents, you could install a 13D system. And from 10 and unlimited up to 6 floors, you could retrofit with a 13R system, and then anything over 6 floors had to be retrofitted with a 13 system.
Sure.
I believe those are the numbers. 4 floors, but I'm pretty sure it's 6.
That's a great approach, because in the States here, a lot of times what we see, because it's kind of the Wild West with the 13R and D code where they're implemented, and we've run into something that was literally a house one day later gets turned into a group home, and all of a sudden it's under 13R, not 13D, and people are saying, well, now you need basically an NFPA 20 fire pump in that house, and it's like, wait a second, it was a house, it literally has 4. So that sounds like a really smart approach to that.
The other issues that came out with it, though, was if it's a new build, it qualifies as a 13R. It was only a retrofit only. You were able to put a 13D system in. So now I had to explain to the customers why the building department was refusing my drawings for a 13D system in a home with 5 residents. Now you gotta have fire alarm wiring. Everything's got to be, the pumps and tanks have to be listed. If we put them in there, we'd always just run a water line into the property for a 13R. But those are just the 3 issues off the top of my head that I could think of immediately. Is why is the home that was existing for 20 years and we had to go and install sprinklers qualify for a 13D with 2 sprinkler design area? Now we have to go to a 4 sprinkler design area for 13R. And
I hear you. And I agree. From a design, I mean, does it make sense from a design standpoint? I mean, is there any logic to that from your end of the field, where like on the design end, is there a logic to it? Because I've never understood it, and I'm curious.
To me, I mean, I want to protect property and life. That's why I'm in this industry, and that's why I do all the things that I do for the industry, is because I've never had a home fire or experienced a fire, but it's probably one of my biggest fears is having that happen to me. So I want to do everything I can to prevent, fire fatalities and property damage from fires. So
Sure.
to me, it's not even so much me, right? Like a 13D system is sufficient to protect the occupants if the building's existing. But if you're building a new home, you have to have 13R, which increases the cost of the construction, which increases the cost of the installation for the sprinkler system, things like that. It doesn't make sense to me from that point of view. I don't think the people who designed the legislation really put as much thought into it maybe as they maybe not should have, but could have.
Yeah.
Right? Because you're essentially saying if you were in a group home prior to this, and we retrofitted your home, you're allowed to have less protection. Right.
Right.
But, if you're just going into one and they're building a new home for you, we'll give you the bet, we'll give you what NFPA is requiring for this system.
Right.
So it's,
that's interesting.
It's one of those things where everybody's got an opinion on it, but in the end, the people who approve the drawings have the last say, right? So I can't.
Absolutely.
That's a retrofit rule only. It applies for the fire code only, not the building code. The building code supersedes you in this case, and I want fire alarm and everything hooked up to this system because it's a new building.
Right.
Yeah. Now, the one I will say, we've used the H2 home, like I said, 5 or 6. I guess there's 2, but that's another Ontario building code thing. My only 2 problems I had with it, it's a 300 gallon and a 400 gallon tank. We have to have, in Ontario, we have to have a 20-minute stored water supply where fire water is stored on site. It's got to be a 20-minute minimum for this application. So
wow.
Yeah, so I get into essentially a 600 gallons of stored water on site. I'd always have to pony up the tanks.
Yeah.
Which isn't a problem, but it was just you guys have a 300 gallon and a 400 gallon. I see you have other tanks available, and I think that's where we got them from. The other issue, and it was something a lot of my guys relayed back to me now, was the overfill or the overflow valve is higher than the fill. The lid on the tank. So you'd have water coming out. Yep. It comes, and even I'm looking at the picture on the website right now. The lid to the tank, which isn't sealed. It's like it's an inspection port, and it's got the vent on it and stuff like that. It will leak prior to the overfill or the overflow, before water hits the overflow.
No kidding. Well, I'll have to take a look at that.
Just a little thing that my guys noticed, and we've never had a situation where we flooded a basement out because of it. But they said, what's labeled as the overflow is higher than the tank, than the lid, which doesn't seal. So
interesting. Yeah, that's where our little float. I think on there, it's like what's in your toilet. That little the little like balloon kind of ball that goes up and down. One quick fix they could do with that, and that's and I'm going to bring it back to our people because there's no reason it should be doing what you're saying it's doing. But they could bend that at say like a 45-degree angle, then it's sitting lower in there. So that might be able to help. But that said, we'll have to take a look at that because we hadn't heard that feedback. I appreciate that.
It was just one of the guys said it, and now it's one of the guys said it and kind of brought it up when we were talking about the pumps and tanks, and then like I said, we've installed 6 of them in the past 6 months. So they were like, why are they all off the top? And it's not the same fitter either. So a couple other people are noticing it. Maybe the guys. Something to think about.
Definitely. Absolutely. I appreciate it. I'll bring it back to our engineering group because it's one of the nice things about the size of our company. We're a small to mid-sized company, and it's nice that we're small enough we're big enough to kind of reach, all of North America. We sell internationally, all that kind of stuff. We have the training room, we have these kind of big company things going on, but we're small enough that like all of our meetings about R&D or engineering and stuff, like we can all go and participate in and give feedback. So it's really nice for us to like when I do stuff like this, have a conversation with somebody, whether it's, it's never been a podcast before, but that's cool. And then but like a trade show or when I go and do presentations, things like that, they say something to us in the class and it's like, oh yeah, we didn't think of that. We ought to address that. And then I could just go back or call our engineers and be like, hey guys, this is what's going on, and we can have a fix for it. So I would hope that the next fix that you buy won't have that issue. So we should be able to affect that. So I appreciate the feedback.
Yeah, absolutely. Other than that, I love I love having the ability to pick something up, put it in place, pipe to it. Very little wiring needs to be done because it's all like a complete unit. Run it to the panel and things like that. But it's all nice. I don't have to worry about really getting anything extra. It's all there and it comes in one single package. It's a very efficient product, aside from getting an extra tank because Ontario's crazy.
Yeah. Well, I'm glad to hear. Otherwise, it's working out for you. That's good. We'll have to think about what we could do for that Ontario market. I mean, I know that we could. The difficulty is making new molds and stuff like that. It gets very expensive, but maybe there's something that we can do in the way of finding a couple of 300-gallon tanks that would work well if piped together. So it's interesting. No, I appreciate
what I'll do is
the perspective.
I'll pop a picture over to you of what we've done in the past as far as poning them up, because we've like with the H2O, it comes with the tank in the pump kind of built into the base of it. But I'll show you what we've done in the past with a couple of your other the economy line of pumps. In the past, we've just gotten two 300-gallon pumps and tied them together, or tanks and tied them together.
Okay, great.
So you guys are going to be at the NFSA convention this year. Where are you guys going to be? Where's your booth? What are you guys going to be talking about at the conference?
Well, I should know that offhand. I don't. We will definitely be on the trade show floor somewhere. But I'm not exactly sure what our booth space is. We actually got a couple of booths. We have 3 spaces, 2 booths together where we're going to have all of our air. So like air compressors, dry air, nitrogen, and we'll be going through all of that. We'll have some of our, we like to bring at least one engineer with us, and then we have a couple of our marketing and sales guys there. So we'll have those guys, and then we'll have a separate booth where we have our, that'll be located in a different spot on the trade show floor, and that's the, where we'll have the H2 home and the residential equipment. So able to talk all of that stuff, yeah.
I'm just pulling it up to see if I can find exactly where you guys are on the I'm just pulling up the list here. So you guys have 2 separate booths. You have one large one with all your air compressors, your nitrogen generators, things like that, and then you're going to have a separate. I can't pull it up quick enough. I'm not going to have a lot of dead time with it.
It'll give everybody the opportunity to walk the whole floor looking for us, and then that way they can find everybody, including your booth. So we're all there, and we're all in it together. So
if somebody wants more information about General Air Products, how can they get a hold of you? How can they find more information?
Sure. You can always, my email's rmfjr, like Robert Michael Frank Jr. at generalairproducts.com. So always available that way. Our website is a great way, but I'll tell you what, and Chris, the one thing we really try to put into people's minds is, and that's why I try to bring up, we're a small to mid-sized business. We answer the phone, like I'll answer the phone. My brothers answer the phone. Our customer service people, when people dial the 800 number, that's all over our equipment, that's all over our website. I don't care if that product is, it's an air compressor that's been running for 30 years. If somebody's got a question, they can call that 800 number, and the person who answers the phone is probably going to be the person who troubleshoots with them or helps them figure out what part it is they need or what's going on with their compressor. So the 800 number is not some distant line in another land or, some, kind of computer menu or anything. I mean, it's Joy or Eder or Mike or Ray DeCecco or Ray or Dave Fremont, Dave English. I mean, this is, we have about 8-10 people answer the phones. and they're all qualified people to help you right away. And if they aren't, if it's something that we haven't figured out, we're going to put you on with the engineer who designed that product. And we'll go in there and sit down there with them. So, I mean, if you're a field guy who's out there dealing with one of our compressors, and our tech reps who are well trained and do this, again, we have a very small focus in the fire protection industry. It's 13D pump and tanks and air supplies. We don't try to be experts in anything else, but we know that stuff really well. So if I can't figure out what's wrong, I'm going to put you on hold. I'm going to send you over to one of our engineers who's responsible, say, for our whole oilless compressor line. And I'm going to sit in his office so that I'm learning, you're learning, and that engineer is telling you what's going on with that. So yeah, that's the best way to get the hold of us is that 800 number, and we're always there to help. So
awesome. Ray Fremont, Marketing Director for General Air Products. Thank you for coming on. This was a very informative conversation, and we'll see you in Nashville.
Right on. Thanks a lot, Chris. I really appreciate it. Great talking to you.
You too. Hey everybody, one more time, I just wanted to thank everybody for tuning in to the Fire Sprinkler Podcast. This was a great conversation with Ray. I hope you got a lot out of it. Let me know if you have any suggestions for future episodes of the Fire Sprinkler Podcast. If you have products that you want to learn more about, if you're a contractor that has a large kind of interesting project that you kind of want to share how you're doing it and why you're the best out there to do it, reach out to me at chris@firesprinklerpodcast.com. Follow me on Twitter at FireSPRK Podcast, Facebook Fire Sprinkler Podcast, Instagram Fire Sprinkler Podcast, and LinkedIn. You can just search for my name, Chris Logan. The Fire Sprinkler Podcast page that I had opened on LinkedIn, I locked myself out of. So, anyways, thanks again for the support. Feel free to leave a review on iTunes if you like the episodes. If you don't like the episodes, leave a review anyways, because that's how I learn. And the entire reason I started doing these podcasts was just so I could learn as much as possible. It was the best way I could get to have conversations with the people that I have so far. So, like I said, if you're interested in coming on and talking about your products, give me an email, chris@firesprinklerpodcast.com, and let's chat. Again, thanks everybody for tuning in.